So this is lesson 4.1. E is in echo, graphs of the sine and cosine functions. And we just started talking about y equals the sine of a number, called it b, times x. And one of the things that we realize is that when this b is anything other than 1, we are going to get a period different than our traditional 2 pi. When that period, or when that number that we put in for b is 1, we get 2 pi. If that number is larger than 1, then we're going to go through this period maybe a lot faster. We're going to get a lot more periods in that 2 pi. Alright, so let's look at determining how big of a period we have depending on that number that we put in there for b. So if we are looking for the period of any equation in the form y equals sine of bx, where b is some number like 3, 4, 5, 6, all we have to do to find the period is do 2 pi over whatever number we put in there. So let's say, for instance, that we have, like in our in 4.1d video, we had sine of 2x. We can find that period by going 2 pi over 2, because this is our b, which means our period took place in 1 pi. If I had the sine of 4x, my period would take place in 2 pi over 4, or pi over 2, because that gives you 1/2. So that means that my period takes place in pi over 2. Or I go through 4 periods in 2 pi. So if that's pi, and that's pi over 2, and that's 3 pi over 2, I go through a stinking period like this. So notice I have 4 periods in that 2 pi, or each period lasts pi over 2. So another good formula for you to have in your notes. To find the period of the cosine or the sine, I put in 2 pi over b, and that'll tell me how far it goes along the x-axis before it starts repeating itself. So if I'm dealing with a sine of bx or the cosine of bx, then my period for either one of those is going to be 2 pi over b, right? So if, for instance, again, I had the sine of 2x, the period of that would be 2 pi over b, which in this case would be 2, which would be pi. So that means in a sine wave it would start repeating itself at pi. So this would be pi. This would be 0. But what would this point be? Well, it would be halfway between 0 and pi, so it would be half of pi. And what would this be? Well, that's going to be a fourth between 0 and pi. Half the way between, actually it's going to be half the distance between 0 and 0 over 2. So if I took pi over 2, half the distance between 0 and pi over 2. So half the distance between 0 and pi over 2 would be half of pi over 2. So I would divide that by 2, which would be, flip it over, multiply pi over 4. So that distance would be pi over 4. The distance between where this point is would be half the distance between pi over 2 and pi. So what is the distance between pi over 2 and pi? Well, if I took pi and subtracted pi over 2 from it, that would give me this full distance here. So this full distance here would be pi over 2. And I'm going to cut that in half, invert and multiply, and I get pi over 4 from this point right here. So it would be at pi over 4 plus pi over 2 in order to get that place, which would give me 4 to 3 pi over 2 would be that point. So very easy, not necessarily quick, but easy to find out where my points are going to be. But let's look at another way to find those points. So notice how many there are. There's 1, 2, 3, 4 points. So we're trying to break this up into 1, 2, 3, 4 quarters. And if we break those up into 4 quarters, we find out some interesting stuff. We find out where the maximum is at the first quarter, where it crosses the x-axis at the halfway point, where the minimum is at the 3 quarters, and where it crosses the x-axis again and starts repeating itself in this one period. So if I can find these, because sometimes this graph is going to be shifted, and the quarter is not always going to be pi over 4, pi over 2, 3 pi over 2, or pi. So let's look at another way in order to do that, to find out where those quarters are, so it makes it a lot easier to graph here. Alright, so if we go back to our y equals the sine of 2x, if we go back to that, and we want to find out the period, again the period is 2 pi over b. So that equals 2 pi over 2, which equals pi. So that's my period. That means that it will start repeating itself between 0 and pi. So that's my interval. That's where my graph will show up, is somewhere between 0 and pi before it starts repeating itself. My endpoints are 0 and pi. My middle points, actually I know one point is here and I know my other point is going to be at pi. Those are my endpoints. I already found those because of this. I know my period is pi and my interval is 0 pi, so those are my endpoints. So what I'm looking for is my halfway point, and my quarter point, and my 3/4 point. So those are the 3 that I'm looking for right now. So how do I find those? Well, I take my quarter point, I'm going to take 1/4 times the sum of my endpoints, which equals 0 plus pi is just pi. Okay, so my first quarter is 1/4 pi. My halfway is 1/2 times the sum of my endpoints. It's 1/2 pi, or pi over 2. My 3/4 point will always be 3/4 times the sum of my endpoints, which is going to be 3 pi over 4. So those are going to be my x values here. Pi over 4, pi over 2, and 3 pi over 4. So those are going to be my maximum points. My quarter and 3/4 are always going to be my maximum and minimum points. My halfway mark, my beginning and end are going to be where I cross the x-axis. So in this particular one, I don't have a number here in front of my sine, so I know that my amplitude is 1. So that makes it pretty easy to draw this. I draw my amplitude of -1 and 1, and I know that's my high point. I'm going to cross there. That's my low point, and I'm going to cross there. So I can easily draw the graph of y equals 2x because I've been given enough information there. So again, these are other formulas that are going to be good for you to have in your notes there.